Hello everyone, welcome back to my channel. My name is Ayush Debe. In this video, I will explain KNN, that is also known as K nearest neighbors algorithm. We will understand what is KNN, how KNN works, whether it's supervised or not, and then we will see its Python implementation with explanation. First of all, what is KNN? KNN is stand for K nearest neighbors. It is supervised machine learning algorithm, mainly used for classification and sometimes for regression. ठीक. Then how KNN works? First of all, in KNN we choose the value of k. Then for the new data point, KNN calculate the distance from all training points. After that, it select k nearest neighbors. Finally, it apply majority voting system and then predict the class with the highest vote. Okay, after this we start code implementation in Python. For this, open Chrome browser and type Google Colab. Open this, open the website and select new notebook. I will delete this again. Start code, import numpy and p, import pandas ed, import mat, pl, o, matplotlib, matplotlib dot py, pl, matplotlib dot subplotl, hpl, okay, import p on edge, yes, and yes, okay, then from skline dot skline dot data sets, skline dot data sets, import import load iris, yes, iris, okay, from again from skline selection, SELECTIO, in selection, import then test stlit split from skline dot linear skline dot pre-processing import import it and a standard scalar from skline dot neighbors skline dot neighbors import K N I G H B O R S classifier. Okay, classifier from S scalar dot matrices M E T R I C S import accuracy QRACY score is confusion matrix MFPRI. Okay, then run this. Okay, code is perfectly run. Here we will import libraries from data handling, visualization, and pre-processing, model creation, and evaluation. Okay, and next, and data equals to load iris iris for this. Run this in front. Next line, x equals to data dot data and y equals to data dot target. 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 Okay, run this. Okay, here I am using iris dataset for x contain input feature and y contain for output class level. Here we will print x for the check the value of x. Here the random values of x. Here we will hide this. Okay, and next step we will using train test split x train T R A I N train in x test by train T R A I N train I test. Okay, and train test yes PL split. Okay, by test size yes size is equals to 0.2 and random state RANDOM random yes T8 T state equals to 42. Okay, then we will run this. Okay, we will split the data into training and testing, and the 80% data is training and 20% for testing. Okay, after this, for a feature scaling, scalar SCL SCALE or scalar equals to standard STANDARD scalar SCALER. This x train equals to scalar 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 dot fit transform x in okay, then x test equals to scalar dot transform yes test yes test okay. For this we will run this code. This is a very important in KNN. We use to data, we scale the data so that all features are on the same range. Okay, create create and train the KNN model. Okay, KNN equals to KNEIGH classifier and underscore NEIGHBORS equals to 3 5 कर लेते हैं तो ठीक है okay, then after this matrices METRIC matrices equals to E U C L I D E A N. Reduction next line ANN dot fit X train and by chain. Okay, run this. Here the output. Here the we create KNN model with K is equals to 5 and KNN does not learn weight. It stores the training data and calculate the distance during the prediction. Okay. Next code, we will predict the value by predict P R E D equals to KNN dot PREDIC predict. Remove this predict. Okay. X test TEST. Okay. Then and the again train by predict. Our predicted value is this. Okay. Now the model is predict the class level for the test data. Okay. Again, we will print the accuracy. Okay. Check the accuracy and print the accuracy. U R A accuracy C by accuracy equals to A double C O R A C by accuracy score by test and by prediction. Okay, then second A double C U R A E by. Okay, run the code. Okay, accuracy tells here the accuracy is tells how many prediction are correct out of total prediction. Here the one prediction are correct. Okay, there is CM confusion matrix M equals to con U US Union confusion matrix fusion matrix by protest y predict. Okay, then SNS equals to SNS dot heat map heat heat map PM and not equals to true here you need true, then F and T equals to page D, then C map, yes map, so C map equals to, give the color blue, BL 2E blues, okay, and this, okay, that are the graph. Okay, next line, PLT dot X LA BL level, and next line we will write in X side we will write X level, prediction level, and Y side we write true levels. Okay, and the title we will write confusion matrix. Okay, PRED did ELT dot by ACTUAL actual ELT dot, so it is a confusion NFUSIO MFTRIX. Okay, run this code here. Okay, I remove this. Okay, then if I remove this, that's show me this. Okay, that's show me a proper wide range of our code. If we add this code, then you can see the actual and prediction. Okay, then we will remove this code, and here we will add the value of k. For example, error equals error rate equals to next or I in range into 40 hit into 40, then KNN equals to KNEIGHBORS plus higher and NEIGHBORS equals to I Okay. We remove change from K. Okay. Next, KNN dot fit shift activate extend by chain by chain. Okay, extend by chain. P T R E to predict. Okay, equals to KNN dot E R E D I C T predict K K test. Okay, and A double R O R error underscore set dot append double P and D and P dot mean PID predict K equals to by PR by test. Okay. After this, we will run the code. Here this is the error because the K is not defined. Okay. For I, here we write I and here we write K. Okay. Then here. Okay. In next line, we see plot plt dot plot range for this we will in the code. Okay, here the we see the graph of error rare versus k value. Okay, to summarize, KNN is a supervised machine algorithm that works using distance. It is simple to understand, easy to implementation, and selecting the correct value of k is very important. For more videos, do like, subscribe, and